Yes, welcome back. In this video, I'm going to show you how to write a chemical formula. Now, we said a chemical formula is a representation of the composition of substance using their symbols and numerical subscripts. Now, steps in naming or steps in writing chemical formula. One, we need to determine the symbol or the formula of the element ion in the compounds. We either have to determine the symbol of the element, the formula of the element, or the ion in the compound. From there also, we need to determine the valency of an element. Remember, you cannot write a chemical formula if you don't know or you're not able to determine the valency of an element or the ion in that compound. And what the valency of an element or a compound is equals to the ion of that particular element or the compound, respectively. Now, from there, you need to interchange the valencies if necessary. The number must always be written as what? Subscripts. Now, let's take example now. If we are asked to write a chemical formula of sodium chloride. Now, here now, first you need to determine this is a compound of sodium chloride. Now, it means you need to know how many elements are present in this compound, sodium chloride. Now, we know there are two elements, sodium and what? Chlorine. These are the two elements that are present. So the first step is you need to determine the symbol of sodium and chlorine. Now, we said sodium is Na and chlorine is Cl. So, that's the next step. The next step is going to be now determine the valency of the element or the ion in the compound. Remember, when we are dealing with how to find or how to determine the valency of an element or compound, we talk about their ions. So it means now sodium, which belongs to group 1, it has a valency of 1. So hence it has a valency of 1. It also has a charge of plus. Chlorine, which belongs to group 7, atomic number 17, group 7, if you want to determine the valency, we said 8 minus 7, which is minus 1. So it means it also has a charge of minus, negative. So it means also it has a valency of 1, valency of 1. Now here now, they say the next one is you interchange the valency if necessary. So hence, there are two valencies here. One valency. They are all 1, 1. And they are all the same. Then we can able to what? Cancel them out. Hence, they are equal. If the valencies are equal, you can cancel out. But if the valencies are not equal and they can able to simplify, you simplify them. Now, we interchange now. We draw our arrows. These arrows are very important. Now, then we write now Na and our Cl. So this is the chemical formula of what? Sodium chloride. Yes, so let's look at another example which we have. Let's say we have calcium oxide. Now, in calcium oxide, we need to determine or we need to know how many elements are present in calcium oxide. There are two elements there. That is what? Calcium, the symbol is Ca, and oxide represents what? Oxygen. Now, from here now, we can know the valencies. Calcium is in group 2, so the valency is 2. Oxygen is in group 6. So we say now if the element exit group, if the electrons in the last cell is more than 4, we subtract from 8. So oxygen has 6 electrons in the outermost cell, so we minus by what? 8. So which means the valency is 2. So hence they are equal. So what do? We cancel them out. Then we interchange. Then we have here now CaO. Always the metal should always come first. If you are writing the chemical formula, the metal should come first, then followed by the non-metal. So the chemical formula of calcium oxide is CaO. So this is the chemical formula of calcium oxide. Now let's look at here now. we have aluminium, let's say aluminium oxide. Again, aluminium oxide is also a compound that consists of two elements, that is aluminium, that is Al, and what? Oxygen. Aluminium is in group 3, so the valency is 3. Oxygen is in group 6, so the valency is 2. That is 6 minus 8. Now, if you want to know now, if you want to write this chemical formula now here, you check whether the valencies are equal. Hence, they are not equal. What do? We interchange their valencies. We interchange them. So, aluminium, we take the 2. You have Al2 as a subscript. The number or the numerical values will always be written in a form of what? In the form of subscripts. Then the oxygen will take the 3. So, this is the chemical formula of aluminium oxide. Now, let's look at another example now. If we have, let's say, we are given, let's say if we are given calcium hydroxide. Now, this calcium hydroxide consists of 3 elements, that is calcium, hydrogen, and oxygen. But hydroxide is a compound of its own, that is which consists of what? OH, hydroxide. And calcium also is an element. So here now, what we need to do here now, we need to know the valency of each of these. This is an element, this is a compound. So let's start with the element. Calcium is in group 2, so it has a valency of 2 or a charge of +2. And the hydroxide here, the valency of oxygen here, or the oxygen state of oxygen here is -2. Now, -2 plus hydrogen is 1, which is going to be now -1, which means now the charge or the ionic is going to be what? -1. Or it also means that the valency of, hence it has a charge of -1, then the valency also of the OH or the hydroxide is going to be 1. So hence also calcium, it has a charge of 2, then the valency is going to be 2. So I'm showing you two ways in which you can able to find the valency of an element using the ionic way or by subtracting them. So now hence now we have here now 2, this one is 1, they are not the same, then we need to interchange them. Now the calcium will take 1 last, as I said earlier on, any variable standing alone has a coefficient of 1 and index of 1. So we don't need to indicate this one. Now this 2 is more than 1, and there are 2 elements here, oxygen and hydrogen. So it means that both the oxygen and hydrogens what are to share this, or this 2 affects both oxygen and hydrogen. So in this case now, if you want to write this, what you need to do is you need to indicate what? A bracket. Then you put your hydroxide, you close it, and you indicate the 2. It means now this 2 affects both the oxygen and hydrogen. So this is the chemical formula of calcium hydroxide. Now, similar example again. Let's say if you are given, let's say, a transitional element. Let's say if you are given, let's say we have iron 1, let's say oxide. I love oxygen too much. All right. So we are given iron 1 oxide. It means also the oxygen state of iron in this compound is 1. So iron is Fe and oxide is O. So it means now iron 1, it means also the valency of iron here is 1 because that's the charge it carries. Yes, iron 1. Let's say the charge is going to be now plus. And oxide is always having a charge of -2. So hence now the valency of oxygen is 2. Then they have to interchange. Now they are not equal. So you interchange them. Now what do you write first? You write the Fe, you bring the subscript number and your oxygen. So this is called iron 1 oxide. Now let's see now the difference, how we are going to differentiate between iron 1 oxide and iron 2 oxide. Now iron 2 oxide, it means now the oxygen state of iron in this compound here is 2. Then what do? You say now Fe and oxygen, you write the elements, the symbol first. Now the valency, iron 2 means the valency is 2, oxygen is here also is 2. Hence they are equal, then they cancel out. then you interchange them. You have here now FeO. So this is the chemical formula of iron 2 oxide. This is the chemical formula of iron 1 oxide.